Hey guys, I want to go ahead and talk about implicit differentiation. So let's talk about regular differentiation. You know, differentiation means it takes a derivative. Now, if you notice this guy right here, it says y is equal to 4x squared plus 2x. If you notice, all this is just in terms of x. So we say this is written explicitly in terms of x. It's explicit. It tells us exactly what it wants us to do. So when we do dy dx, it's telling us, okay, take the derivative, okay, with respect to x, okay, the derivative of y with respect to the x. So we're just going to be taking the derivative of this guy, and actually what's happening here is we take the derivative of this guy, 2 times 4, well, that's going to give us 8x. Now, because we're taking the derivative with respect to x, okay, we don't have to go ahead and do any more simplification. Okay, and then the derivative of 2x is just 2, and that would be your derivative. But if you notice here in this other example here, we have d dx. We have to take the derivative of x with respect to this guy here. But there's a problem here. This guy's an x, this guy's a y, so there's a difference here. Now, it's a little bit too difficult to understand, but you can think about this as a composition function. So you can think of it as, you know, the first function is your y, okay, and then your second function is your actual x cubed. So it's almost like the y is hidden inside of the second function, okay. You can think about it that way. So we say that this guy it's implied, it's implicit. So it's telling us there is an x function, it's just somewhere hidden inside. So what we have to do is we're going to go ahead and take the derivative, okay, and the way we write it is, let's go ahead and do d dx y cubed. We're going to go ahead and take the derivative of y cubed, which is 3y squared. But because it's a y, okay, and there's the other function inside, okay, this is with respect to x, this is with y. Because there is this y function inside, we have to take the derivative of that guy, and then we do dy dx, okay, and that would be my derivative. Okay, we don't know what this x function is. All I know is that I have to find out. What do? Well, we find out what it is by saying dy dx. Okay, why? Because it's hidden inside. Okay, much like if this guy were hidden inside, okay, and we would have to go ahead and do kind of like the chain rule. All right, so let's go ahead and take a look at some examples here. And you notice these guys are written in XY format. They're written explicitly because you notice it's not y equals, okay, in terms of x. So 3x, okay. So the way we do it, we take the derivative just like we normally do, but every time we have the y, we're going to go ahead and put dy dx. So 3x, okay, the derivative of 3x is 3, okay, minus 2, the derivative of 2y is 2, but because we have the y, we're going to put dy dx with the derivative of y with respect to x, okay, plus the derivative of 6 is 0, equals 0. Okay, so our answer is 3 minus 2 dy dx is equal to 0. And a lot of times they're going to ask you, find, well, what's a slope? Well, all we go ahead and do is we're going to go ahead and solve it. Take 3 over and then divide by -2, so that your answer should be 3/2. So this is telling you that the slope of this function is 3/2. Another way of looking at it, guys, is you see how it's x and y, and this is in terms of y, dy dx, okay? So let me just go ahead and do it over here. Well, if I take the derivative of 3x, we know that's 3. Okay. Now, if I would go ahead and do this same process here, well, that's an x, right? Well, that means we're taking the derivative with respect to x. So this actually would be dx over dx. Okay. Why? Because it's in terms of x. Now, what about this guy? Well, this guy is a y. Okay. Minus 2. Well, the derivative of 2y, well, that's just a 2. But because it's a y, we're taking the derivative of y with respect to x. Now if you notice dx dx, well, that just becomes a 1, and then we're left with 3 minus 2 dy dx. And then we just continue and solve it, and that's another way of looking at it. Okay, so let's go ahead and take a look at the next problem. Let's do some of these. Let me just go ahead and make some room over here. We'll just go ahead and start making it a little bit more complex. The derivative of y squared, well, that's 2y. But because it's a y, we're going to go ahead and tack on a dy dx. Okay, minus the derivative of 3x as well, that's just 3. If you want to go ahead and do dx dx, that's perfectly fine. Plus the derivative of 2 is 0 equals 0. Now, notice that I have dy dx, okay? Now, if you want, you don't have to put dy dx. You can put 2y times y prime. Is that the same thing? Yeah, it is. Minus 3 equals 0, okay? So, now we go ahead and solve, and let's see, y prime is equal to, take the 3 over, divide by 2y, and there it is. So what does this mean? That means that the slope of this function would be given by 3 divided by 2y. And that's all it is. Okay. Let's go ahead and make it a little bit more complex. Let's see if we can do this a little bit quicker. Derivative of x squared, oh, that's 2x. The derivative of 6x is 6. The derivative of 4y is 4. But because we have a y, we're going to put dy dx. Or you can put y prime. The derivative of 2y squared, that's going to be 4y times dy dx. The derivative of 13, well, that's 0. Okay. Now, I like this problem because we have to go ahead and try to combine stuff here, okay? So, I got to kind of somehow combine these dy dx's together. So, what I'm going to do is I'm going to take the 2x plus 6, take them to the other side, and I'm left with, let's see here. I'm going to put this guy in the front first. So, I'm going to go ahead and put 4y dy dx, and then minus 4 dy dx equals, take the 2x and the 6 over, so that's going to be negative 2x minus 6. Okay, so I just brought those guys over here. Now, how do I combine these things? And what I'm going to do is I'm going to actually factor out the dy dx. So I'm going to take these guys out, okay, factor it out. That's the beauty of this. Factor it out, and I'm left with 4y minus 4 equals negative 2x minus 6. And then the last thing I have to do is just divide by that 4y minus 4. So dy dx is equal to negative 2x minus 6 divided by 4y minus 4. And there it is. That would be my slope of this particular function, if it is a function. A lot of times they're not. All right, guys, let's go ahead and do the next one. This one might be a little tricky. If you notice here, you see that x and the y together, we're going to have to use the product rule. Okay, so make some room here. Derivative of y squared, well, that's 2y times y prime plus. Now I'm going to use the product rule, okay? So I'm going to go ahead and just kind of do it brackets so I don't confuse myself. So first times the derivative of the second. The derivative of y is 1. But because I'm taking the derivative with respect to y, I have to put a y prime. So first times the derivative of the second plus the second times the derivative of the first. The derivative of x is just 1. Okay, so I'm done with that, guys. So I'm just going to close them off. Plus the derivative of x squared is 2x minus 2 equals 0. Okay, so that's what I have right now. Okay, so let's go ahead and continue it on. Okay. Let's see here. Let's clean it up. So we got 2y times y prime over here plus, let's see, that would give me xy prime plus y plus 2x minus 2. And that would give me equal to 0. These guys, I'm going to keep them on the left, everything else on the right. So I'm going to have 2y times y prime plus xy prime is equal to, take this guy over, so I'm going to have, let's see, negative 2x, negative y plus 2. Okay, Same thing over here, factor out my y primes, y prime, and that's going to give me 2y plus x is equal to negative 2x minus y plus 2. Lastly, just go ahead and divide everything by the 2y plus x. So my y prime is equal to negative 2x minus y plus 2 divided by 2y plus x. And a lot of times what you're going to see in the AP exam is that these suckers right here, especially the product rule, those guys are notorious for using that. So just go ahead and be ready for that. I want to go ahead and do just a few more, just to kind of give you guys a good amount of examples. Same thing, product rule right here. Okay, so we'll just say that this guy here, the 3x, we'll call that our first function. Okay, so the first function times the derivative of the second, which would be 2y. And then because it's with respect to y, I'm going to put dy dx. First times the derivative of the second plus the second times the derivative of the first. The derivative of 3x is 3. Plus the derivative of x squared is 2x. Minus the derivative of y is 1. But because we have a y, we have to do dy dx. Minus the derivative of x is 1 is equal to 0. Okay, so sometimes these guys get kind of long. Let's go ahead and combine these. Can I do these two together? Yeah, I can. They're constants. So this becomes 6xy times dy dx plus that becomes 3y 3y squared plus 2x. I'm just going to go ahead and omit that 1, so I'm just going to have dy dx. Let's see, minus 1 is equal to 0. So hopefully by now you're starting to see the hang of it. I'm going to keep my dy dx's on the left, everything else, 3y squared plus 2x minus 1, take it over to the right. So let's see, how can I do this? 6xy dy dx minus dy dx equals, I'm going to take everything, 3y squared, this guy's all the way to the right. So that becomes, let's start off with, let's see, negative 3y squared minus 2x plus 1. Same thing, factor out the dy dx. Okay, dy dx. And that becomes 6xy minus 1, don't forget that 1. Okay, equals negative 3y squared minus 2x plus 1. And it looks like I ran out of room here. And that's okay. Let's go ahead and just kind of continue it over here. Okay. So from here, all I have to do is divide. So when I go ahead and divide, dy dx is equal to negative 3y squared minus 2x plus 1 divided by 6xy minus 1. So what does this tell you? This tells us that the slope of this particular function is given by this, ratio right here. Okay, and that's what that means. And a lot of times they'll give you x and y, and then you plug them in, and it'll give you the specific slope. Okay, at that particular point. All right. So let's say, for example, find the slope at, I don't know, 1,4. Well, you just plug in your x, plug in your y right here, do the math, and then you'll get your answer. Okay, but I won't do that today. That's just because we're practicing the technique. All right, we'll do another one. Okay. All right. Derivative of x squared, 2x minus. Now here's what I'm going to do with this guy. You see that minus has to be distributed with everything. But what I'm going to do is I'm going to take them out so I don't confuse myself. Okay, and then I'm just going to go with x and y and do the product rule. So the first one is x, this guy right here. So the first one, first times the derivative of the second. The derivative of the second is this y. The derivative of y is 1. But of course, because of the y, we have to put dy dx plus the second times the derivative of the first, which would be 1. So I'm done with the product rule, so I'm going to close that guy off. Now, the derivative of sine is cosine y. But again, because I'm doing with respect to y, I have to go ahead and I'm running out of room here. Tack on that dy dx. Set it equal to 0. Why? Because the derivative of 3 is 0. So let's go ahead and clean this guy up. Let's go ahead and distribute this negative. So 2x minus x dy dx minus y plus cosine of y dy dx is equal to 0. Okay. So same thing, I'm going to keep my dy dx's on the left, everything else on the right. So I'm gonna go ahead and put this guy here first, just because it's positive. So cosine of y dy dx minus x dy dx is equal to, everything else is on the left, negative y becomes a positive y, positive 2x goes over, becomes a negative 2x. And the reason I'm doing that is just because I don't want to have that leading negative in front of here. Let's go ahead and factor out your dy dx's, dy dx, and that's going to leave me with cosine of y minus x equals y minus 2x. Lastly, I'm going to use y prime. Divide everything by cosine y, so that's going to give me y minus 2x all over cosine of y minus x. And whoops, sorry guys. Okay, so over here, if you noticed, I went ahead and this guy, I wrote them out first. Cosine of y dy dx minus x dy dx equals, and then the 2x becomes a negative on the other side, then negative y becomes a positive, and then factor out the dy dx, and then you're left with this guy, and divide, and you're done. Last one. Okay, thank you guys for your patience. This one's a little bit easier, seems like it. So this guy becomes 4y cubed times, of course, y prime. The derivative of y is 1, but of course, because with respect to y, it's y prime. Derivative of 3x is 3. The derivative of 5 is 0. All right. So from here, makes it a lot easier. Let's see here, 4y cubed times y prime plus y prime is equal to 3 on the other side. Factor out your y primes. You're going to get 4y cubed plus 1 is equal to 3. Let's go ahead and divide 3 divided by 4y cubed plus 1. And that's your answer. So hopefully that helps, guys. I try to give you as many examples as possible. But shoot me an email if you guys have any other questions. All right, guys, good luck.